Okay. All right, let's go here. All right. Hello, hello, hello. Hello, everybody. Hello. Hello, hello, hello. How we doing today, everybody? How we doing today? I hope we are doing good. All right. Get this going. So that thing that I wanted to see. There it is. That is what I wanted to see. Those things. There we are. And so, oh, make adjustments to this. All right, there we go. Hope everybody's doing well. Hopefully everybody's doing well. How's everybody today? Just gonna cut that down a little. I'm very good, Brenton. How was your weekend? I hope you had a really good weekend, man. Oh, sorry. Yeah, I had a really good weekend. It was nice and relaxing and things like that, and gearing up for the final week here. Well, final couple weeks technically, but yeah, we're in pretty good shape in all honesty. So take a look here really quick. So hopefully you're doing pretty good. Yeah. So we're gonna have a lot to talk about here today, but we got to get through the material here for today, and then we're gonna go ahead and take a look here at take a look at a little bit of material, and then which is the last of it, and then we'll go ahead and talk about the test there and stuff. So that's what's on the agenda here for today. Is we need to get a lot of things out of the way, so that way we can at least acknowledge a couple of those things. So all right, good beans, good beans, good beans. Everybody's a winner. At least I hope you're a winner. I feel like a winner. I hope you're a winner too. Okay, good stuff, good stuff, good stuff. Alrighty. We're going to wait just a couple more minutes here, and then we're going to go ahead and get started here, okay? A few more people will start to trickle in, and then we're going to get going here with the latter half of the textbook. Let's go ahead and shift focus to the main screen here. Go. My math lab page here. Ah. There we are. Good bins. Okay. I need I'm gonna get this. I don't know, and it doesn't. All right. Move that over there. All right. Okay. Get going here in just a moment. I'll wait for the clock to switch over to 10:05, and then I'll get going. Hello. Can I draw the graph of cotangent squared of 3x plus 2 sine x? I mean, I could draw the graph of cotangent squared of 3x. Plus 2 sine x kind of throws it into the mix, but let's see if we can take a look at the graph nonetheless. So, you sure you have to draw the graph? That's a pretty complicated graph, in all honesty. Yeah, what was that side again? Oh, yeah. It's a fair question, though. I mean, really, you should just like plug and chug numbers in, to be perfectly honest. Really, that's pretty helpful. You do have a, although you, to be fair, you do have a rather complicated question there. 3x, triple that angle there, plus 2 sine x. Is that a, I haven't seen one of those in a while. Yada, 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 boring. The question does say to draw the graph, not solve for it. Okay. So what I would do is that if you're not sure what that graph necessarily looks like, okay, so if you were to look at like I mean, there's a lot of intervals here, to be fair. There could be asymptotes to go along with that. Here's what the graph looks like. Looks a little messy to me. But wow, that's a pretty complicated graph to look at. You sure it's a plus 2 sine x? What kind of trig class are you in? Is that graduate level math? Or is that regular trig class? So if it's like a graduate level, oh, that's why. Yeah, so here's the way I would do it. You could find the domain of each individual function or try and find the period. You could also try an XY chart here as well. So here, for example, you could talk about where the asymptotes are located. based on that, here's a good way to kind of talk about the steps here on this little chart here about how to find the vertical asymptotes, so you know what the representation of one period of that function is going to be. Um, and obviously, you want those asymptotes to work out there, and of course, you want to check out your domain of each function here, so you can find one period of the function and then just basically copy paste after that. So essentially the way you want to do it is like you would regular graphs, is basically just find what one period of that function is going to be, and then find, of course, your 5 major points within that period of the function, and then go ahead and then just kind of repeat said process here, because that's exactly what you're going to get here in this case. Is, as you can see here, is just again the best way to put this type of graph here. I haven't done that in a while, to be perfectly honest with you, Metal. But that's the strategy that I would probably take, is probably just going back to the basics there. X squared plus x plus 1 can be factorized to x minus z squared. I'm not sure how that's possible. You could quadratic formula that stuff, and then you can find the two factors, which I imagine will be imaginary. Is that correct? Yeah, that would be imaginary there. Yeah, z is complex, that's correct. Z would be definitely complex there. So in that case, right? So in that case, if you had x squared plus x plus 1, you have to do the quadratic formula here, which again is negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, you're definitely going to get complex roots here, without question. All right, and since a, b, and c are all 1, all right, a is 1, b is 1, and c is 1, you just go ahead and plug that in. So you get negative 1 plus or minus the square root of b squared, which is 1 squared, minus 4 times 1 times 1, and then all over 2 times 1. So what you're going to get here specifically is you're going to end up with, you're going to end up with negative 1 plus or minus the square root of, this is 1 minus 4 in here, so that's going to be negative 3. So you get the square root of minus 3 in here over 2. So if you were to actually put this together here, okay, in a proper form, then what you could do here is you can rewrite this as negative 1 plus or minus the square root I times the square root of 3. Remember that I here is the complex number that you're referring to here. I is again the square root of minus 1. And so here you get this over 2. And so you could break this up into two factors here. This would be x minus the quantity negative 1 plus I squared root of 3 over 2. And x minus negative 1 minus this I squared root of 3 over 2. So that's how you can show the factorization of that. Yeah, no problem, dude. It's not as bad as it seems once you just put those 2 and 2 together there. So you just have to, again, just make sure you use that quadratic formula, because you tried it the regular way, right? And you realized, oh, I can't get the middle term to work out. Like you get 2x. So the only way you can get complex numbers is you have to do the quadratic formula. You don't have a choice in that matter, unfortunately. But that's our last resort, so that's why I went to the well there. So just to give you a heads up. Okay. Oh, sorry. Went a little overtime there. Sorry about that. Okay, we got some stuff to do here. All right, let's do it. Okay, let's get started today. Welcome back. Welcome back to Monday. Hopefully, a nice weekend. All right. Um, I'll answer that question here once I'm done. I got a lecture to do here really quick, Dr. Dags. So let me go ahead and do the lecture here, and I'll answer that after I'm done here with my class. I'll be happy to answer that for you, though. No problem. Um, okay. So today, we're going to go over the latter half here of section 10.2 and section 10.3. Okay, that's what we're going to end up doing here today. That's the last couple of sections here from the textbook. Now, we did the first half of section 10.2, which talked about SOHCAHTOA. Okay, we talked about how to actually find sine, cosine, and tangent on a right triangle. Okay, we talked about how to set up a right triangle, of course. That was very important, where each angle is opposite of their respective side. Okay, so we discussed about that here last time. Now, we did end off here halfway through, and the particular reason why we ended off here halfway through is because of the fact that um, here in this particular instance, we wanted to find, let's say, an angle from an expression. So we're gonna go ahead and do that here in this case. Hey, Gomesh, how are you doing, buddy? I hope you're doing good. All right. So this is going to be important here for the last section that we're going to be doing here in section 10.3. Okay, so we need to go ahead and find out how we go backwards from saying taking sine, cosine, having that equal to some number here, and then finding the respective angle that goes with that particular number. Okay, so let's go ahead and discuss about that here, and let's see how we can go ahead and do that. Now, in all reality, there's no way we're going to actually do this by hand. What I do expect you to do, though, is actually find this via the calculator. Obviously, with random decimals floating all over the place, well, it makes sense that we're going to have to go and use the calculator here in order to go ahead and find that out. So if you have a calculator there, um, I want you to take that calculator out. You can only find it via the calculator here. So if you don't have a calculator here, it's going to be nigh impossible for you to do. All right. But let's go ahead and take a look at several problems here, and let's see how it works out. That out. Okay. So let's take a good look here at this first one here. Let's say sine of A is equal to 0.974. All right. So sine of A is equal to 0.974. Now our goal here in this case is to find the angle A that satisfies this expression. Now this could be sine or cosine or tangent. It doesn't really matter. What really matters is the process here. Now, underneath the normal process, what we would do in algebra, when we talked about algebra a few chapters ago, is let's say I had, say, 3x equals 12 or something like that. Now, normally what we would do is, in order to solve for x, I would divide by 3 on both sides. And then, in this case here, divide by 3 on both sides, you get 12 divided by 3. And then naturally here, x is equal to 4. Okay, so, all right, no problem there. We're pretty comfortable with that at this point here, doing some simple algebra. However, here's the big difference between what we do here for regular numbers and what we do here for this particular example. The biggest difference is that sine is not a number. Okay, sine is a function. All right, so sine is a very specific function there, okay, of trigonometry here in this case that we apply to an angle that somehow miraculously gets 0.974 at the end of the day. So the real question becomes is like, okay, well, how do I get the angle A here? How do I effectively divide sine on both sides to get angle A to be left over? Well, let's talk about the key here. The key here is that if we want to divide functions, we actually have to take the inverse. So to take the inverse sine of both sides. Now, the way we write inverse sine is like something like this, like sine to the -1 power. And this will be important for one reason, is because you'll actually find this also on your calculator as well. Now, we have to do it to both sides here. So we have sine inverse, and we take sine inverse of this side as well. So the sine inverse and sine effectively kind of cancel each other out, and that leaves you with angle A here, which equals sine inverse of 0.974. Now, another thing to be very careful about is if you're using a basic calculator here, or heck, even using a graphing calculator, make sure that your calculator is set to degrees. It shouldn't say DEG, okay, on a basic calculator, or on a graphing calculator like the TI-83 or something like that. You want to go ahead and hit the mode calculator, the mode button, sorry. You want to hit the mode button, and you want to scroll down to radians and degrees, and you want to highlight degrees and hit enter. So much as what you see here on my screen here. All right, I'm just going to put it up like so. Okay, yeah, I'm just kind of adjusting here. There we go. All right, so it should look like that. You should have it highlighted, and then you can quit to the main screen just like that. Okay, so let's go ahead and I'll show you here. Make sure that everybody gets this correct here, okay? So that's the important part here. Let's see if everybody gets this right, because I want to be sure that you're using the calculator here correctly, because this will be important here for what we're going to be doing in the next section anyway. Okay, so if we put that correctly here and you get the amount of degrees, typically I think even the homework here will go out to like a couple decimal places. So in this case here, what you should get is 76.91 degrees, okay, in this case. All right, now I want you to go ahead and try this on your calculator, and you should match the same exact answer here is to get 76.91 degrees, you know, again, rounding off to 2 decimal places. So once you guys have that, okay, go ahead and type yes in the chat, so that way I know that you got that there through the calculator appropriately. So I just want to be sure that you get the button presses down, so that way you'll know how to attack some of these problems we're going to look at in the next section. All right, yes, okay, good. Got it, okay, good, Dr. Dan. JC, how about you? Got it? Okay, cool. Excellent. Nice, nice. Okay, so now that we got that, okay, again, the button presses here are very important, because again, this will be applicable for what we're going to be doing right in the next section. Let's try one more here, okay, just to kind of hammer the point home. Let's try one more point here, okay, and let's see if you guys got this down. This time I'm not going to write down the answer. This time you guys tell me the answer. We'll round it to 2 decimal places. So I'll pick that tangent of A is equal to 0.872. I'll pick that one. Okay, so just put that down here real quick. Okay. Again, what we're going to do here is we're going to just take tangent inverse of both sides. Okay, separate this out here. And then let's go ahead and, again, we're just going to find out tangent inverse of 0.872. All right, is equal to capital A. Okay, now try that on your calculator there, and I want you to tell me what the final answer is going to be. All right, again, round to 2 decimal places here, and type your answer there in the chat. Okay. 60.69? I want to try that again. Make sure it's set to degrees. Unless you did accidentally like inverse sine or inverse cosine. Remember, it's inverse tangent. It's a different button. Yeah, you did inverse sine there, Brenton. You need to do inverse tangent. Actually. Oh, there we go. All right, perfect. Okay, so that is the correct answer here. All right, just making sure. Again, you will get, as you can tell, Brenton, yeah, you do get significantly different answers depending on which function you use. So you just got to be careful about that. All right. So 41.09 degrees, perfect. Okay, and there we go. All right. So we're not talking super hard here. Again, just be careful about which one you wanted to use, which one you have to use, but that's okay. All right, not a problem. All right, now in this instance here, let's go ahead and talk about a couple of a few examples here in the next section over. Okay, the last section here. We're going to discuss here specifically. We're going to discuss here specifically applications that are going to use these sine, cosine, and tangents. Okay, let's go ahead and see what we're working with here. All right, let's go to that last section there. We're going to look at several problems. All right. So a lot of times in these problems here for applications, it's going to be good to get a good visual representation so you know exactly where things go. Okay, and of course, kind of getting to know some of the terminology can't hurt either. All right, there we go. Okay, so we're going to look at number 4. Okay, so number 4 here you see right in the middle of the screen. Let's go ahead. Actually, I'm going to move that away from my face. There we go. All right. Okay, so number 4 says a helicopter flying directly over a fishing boat at an altitude of 1,200 feet spots an ocean liner at a 15-degree angle of depression. How far from the boat is the liner? Okay, let's talk about two things here. All right, that are rather important. So we're going to come back to the picture in just a second. But I'm just going to go ahead and define a couple of things here right off the bat. First and foremost here, they talk about angle of depression or angle of elevation. You may have heard of these terms before, but if not, no biggie. So what is angle of depression? They're not angles that make you sad. Okay, that's math makes you sad, but maybe not in that way. An angle of depression basically is the angle that is made uh angle that is made when looking straight down. When looking down, um, starting from a horizontal base. Okay, so let me go back to the picture here for just a moment, and I'm gonna just kind of do a half and half here for just a second, and that is so. Let's take a good look here at the picture, okay, and let's look at the angle of depression here. So basically, to put it into context here, an angle. Let's say you're at the top of an observation tower. So let's say you're going to like a tourist destination, and it happens to be like a tower sort of thing, and you happen to go to the top of the tower. Like let's say you go to like the Sears Tower, okay, downtown, and you're like, okay. I want to look down at the city. Okay. Well, the angle of depression is how you know the angle that you look down at the city. So that's compared to looking straight ahead, which would be just a straight angle, and then looking down here, what's this angle that you make right here? So as you can see here on the picture, that's what the angle of depression kind of reflects in looking ahead and then making that angle when you're looking down at whatever you're looking down at. Okay, so that is reflective of the angle of depression. All right, as you see, the other half is the angle of elevation. Now, the angle of elevation here is fairly simple. That actually doesn't require as much, but the angle of elevation is, again, angle that is made when looking up, starting from a horizontal base. A lot of people like this one here only because it's a lot easier to understand. Again, it's just like, okay, I'm looking up like this, and starting from the ground level, here's the ground level, here's me looking up. Okay, what angle did I make here with the ground? Okay, when I looked up. Okay, so starting from a horizontal base, let's say that's the flat to the ground, and when I look up, I'm like, okay, I make some sort of angle when I look up. So angle of elevation, angle of depression. Again, as you see there, how it works. Now, having said that, let's go ahead and take a look back at our picture here, because we're going to need to go ahead and see what this picture is going to look like here when we draw it out. So as we see here, we have 1,200 feet from the sailboat, from this boat here up to the helicopter, and it sees this ocean liner, some amount of feet away. So let's draw the picture here once again. So this is our right triangle here. We know that from the boat here to the helicopter here is told to us in the problem as 1,200 feet. So the helicopter is 1,200 feet in the air. And what they ask us specifically here in this problem, and this is the part you have to be careful about. Let's go back for just a second. Let's expand this out. It says, how far from the boat is the liner? So how far is this boat here that I'm circling with my mouse away from this ocean liner out here? Okay, so what we're trying to find is not this diagonal. We're trying to find out this distance, this leg of the triangle down here that goes straight from the boat straight to the ocean liner. So when in effect, what we're trying to find here is we're trying to find this x down here with this angle of elevation or angle of depression, whichever way you want to look at it because they're congruent. This is going to be 15 degrees. Okay, so we want to find this x that you see here in this problem. All right. Now let's think back to what we talked about last week, okay? Because last week what we talked about is, okay, we've now defined SOHCAHTOA, and now we can find any which value we want on a right triangle, just have to figure out what exactly we're trying to solve for. So in this case here, we're trying to solve for x. Okay, so I'm given this one side of the triangle here being 1,200, and I got this x here, which is the bottom part of that triangle, the other leg, and I got this degrees here of 15. What's the best trigonometric function to use here in this case? Is the best trigonometric function to use is going to be sine? Is it going to be cosine? Is it tangent? Is it tangent of 15 degrees? Okay, that's correct, JC. Tangent of 15 degrees is correct. Now let's talk about why. All right, tangent, if you recall, let's go back here. Tangent was the TOA part, T-O-A. And so tangent here specifically says the tangent of some angle is equal to the opposite side divided by the adjacent side. Notice the sides that we're given here in the triangle. We're given the opposite side, and we're trying to find this adjacent side of this triangle. Okay, I don't care about the hypotenuse here. The long diagonal, the hypotenuse doesn't matter here because I'm not trying to find that distance. I only need two sides here, and that is the opposite and adjacent side, and tangent definitely fits the bill in order to put two and two together. So I agree with the JC there. We're going to take tangent of 15 degrees. All right, and then we're going to take the opposite of that. The opposite of the 15 degrees here is 1,200. And then we're going to divide that by x, okay, which is the adjacent side that we have here. Okay, before we move forward here, are there any questions? I want to be sure that that made sense about why we chose tangent. No? Okay. That's fine. Okay, now let's take a good look here on how we can solve for x. Okay, so if you're not sure how to solve for x, it's not too hard, but again, just you can keep this in your notes here. Again, we just want to get x by itself. Unfortunately, we have 1200 divided by x. So what we're going to do here actually first is we're going to multiply by x on both sides. You can multiply variables as well. That's fine, as long as you're balancing it out. That's not a problem. So right now we have x tangent of 15 degrees. Again, tangent of 15 is some random number. I don't know what it is, but it doesn't really matter. And now, with tangent of 15 being some random number, random decimal number, again, it doesn't matter much to me, I'm just going to divide by tangent of 15 on both sides. So I can cancel this stuff out. And so now I just, on my calculator here, I should do 1200 divided by tangent of 15 degrees. And does anybody have an answer for me here? We'll go to 2 decimal places here again. Anybody have an answer for me? Oh, thanks, Connor. Let me hydrate there. Oh, right. I got a little coffee left. I hydrate using the coffee. Copying hashtag. It's very useful. I ain't gonna lie, Connor. The posture check and hydrate stuff is actually fairly useful. I get really lazy with my posture and how much I drink, so I ain't gonna lie, it's actually fairly useful. Anything I'll find practical, doesn't matter. Emulation, not a problem. The practicality is good. 4478.46. Okay, that is correct. All right, very nice. I believe this is I believe it's feet. Yeah, it's feet. That's right. Hey, I appreciate that, Connor. Love you, buddy. All right. Hopefully I make it that far. But I'll just do the best I can right now. All right. Okay. So that's number 4 there in that case. All right. Very nice. Very nice. Any questions about that before we move forward? No? All right. Perfect. Okay. All right. Let's move on here to the next question. All right. So let's see which one I want to do next. There are specific problems in here I do want to do, and they have to be addressed. All right. Yes. Okay. Let's show a practical problem here, and I want to do that one there. So go to specific question. Alrighty, here we are. So here's a place where trigonometry is fairly useful. All right, so let's look at number 18. Okay, so number 18 is one of the nicest problems here we can talk about trig. So number 18's police science. Detectives investigating a crime find a bullet hole in a wall at a height of 7 feet 6 inches from the floor. The bullet passed through the wall at an angle of 34 degrees. If they assume that the gun was fired from a height of 4 feet above the floor, how far away from the wall was the gun when it was fired? Round to the nearest foot, and we see the figure. Okay, so we can see here exactly, kind of what the story is regarding this. All right, we have again two triangles here. We got we got a triangle here in this case, and we want to figure out how far away this gun was from the wall here when they investigated the crime scene here in this instance. So this does have really good practical applications, and again, this is actually used. All right, so obviously this is a more of a simple example, but still, it has its relevancy nonetheless. Okay, so let's take a good look here and draw a picture. One of the things that would be very helpful here, drawing a picture will be immensely helpful. So that way we can put two and two together. Okay. All right. So go ahead and take this out. Boop. Let's boop that out of existence. All right. So in this case here, we're gonna have we're gonna have a couple of triangles of which to work with. So number one, let's talk about now the gun here was 4 feet above the ground. So we're gonna make that assumption here in this case. Okay, so let's make a right triangle with what we have here. So I'm gonna have a triangle go up like this, goes up the wall like this, and then it comes back down. Okay. So we have this length x, which is where the distance from the gun to the wall is going to be. That's what we're trying to find. Now, since the gun was 4 feet above the ground, what's this distance on the side? What's this distance that you see here on the side? What should that be? Take a look at the picture here. This is 4 feet here, okay? This is 4 feet here, and this is 7.5 feet from the base of the wall all the way up to where the bullet hole was. Well, I'm talking about here, in this case, Brendan, it's not exactly 7.5 feet because I'm talking about, all right, here's the gun and here's the wall. The gun is 4 feet in the air already. So what's the distance between here in the middle all the way up to where the bullet hole is? So it's kind of part way up the wall, if that makes sense. Like where this horizontal distance is, and then working our way up from there, going up. So what's that distance going to be? A 3.5 is correct. So think of it this way. From the base of the wall to the bullet hole is 7.5 feet. All right, from the base of the wall is 7.5 feet, but the gun's already 4 feet above the ground. So you have to subtract 4 from that. So that's where you're going to get the 3.5 from here in this instance. Yeah, that's right. That's right. So we're going to use the decimal equivalent here, Brenton, okay, which I agree is 3 foot 6 inches, but using the decimal equivalent here so we can put it in the same units, that's going to be pretty helpful for us. Okay, now comes the trickiest part, in my opinion. Yeah, just making sure we get the context here correct, because that's important here, no question, okay? No question about that. Context is very important. Okay, so let's take a good look here at this case. Now, the last part here that is confusing is the angle that the bullet made with the wall. What it did make is that it's 34 degrees, but this 34 degrees represents this interior angle in here. we want to represent this angle right here, which starts from the face of the wall, not inside the wall. Okay. So if you take a look here carefully, here's how it works. Here, okay, this is probably the crux of the problem here, is determining this angle. Because here we have 34 degrees, all right over here. Then we have the rest of it left over. Now, if you talk about a straight line here, that's a straight angle. And so from here all the way over here is 180 degrees. So you first take the first 34 degrees, then you take away the next 90 degrees because it talks about this 90-degree angle here. And then you have the rest of it left over. So if you're talking about this angle, we'll call it angle A. Whatever, we'll call this angle A, which I'll label here in just a second. But this angle A basically states, all right, this should be 180 minus the 34 minus the extra 90 that you make with the perfect 90-degree angle with the wall. And then that should tell you what angle it made with the face of the wall and not inside the wall. So if we subtract these guys from each other, what do we get here in this case? So 180 minus 34 minus 90 is what? 56. Very good. Now, before we move forward here, are there any questions about how we justified finding that angle there? Does that make sense about where we came up with that angle? Yes? Okay. That doesn't make sense? Nope. Yes? Okay. Okay. Good. I want to be sure that it makes sense about where I justify. Okay. I just want to be sure that it makes sense about to justify where that 56 had come from. Again, if you need to visualize it just a little bit more here, again, you can draw the extra triangle out here that goes a tad bit further here. Here you have the 34 from the picture. Then you have this extra 90 here. And the rest of it is the actual 56. So you need to draw that in just to see it visually. You're like, okay, fine, there you go. All right. Okay. Now, we still need to solve for x here. That part is true. So, obviously, we're going to use a trigonometric function here. We're going to take sine, cosine, or tangent of 56 degrees. Which one should we use here in this case? Should we use sine? Should we use cosine? Or should we use tangent? Tangent of 56. That is correct. Very good. That's right. So let's use tangent of 56 here. So again, remember tangent here is the TOA part, T-O-A, opposite over adjacent. So the opposite side of 56 is x, and the adjacent side is 3.5. Now, if we're going to solve for this here appropriately, we're just going to multiply by 3.5 on both sides. And we're going to bit bop boop that in the calculator. We're going to see what we get. Okay. So what's that going to be here in this case? What's 3.5 tangent of 56? Let's go to 2 decimal places here again. All right. Spot on, everybody. Nicely done. 5.19 feet. Nice. Okay. Good stuff. All right. Nicely done, everybody. All right. Very, very good. Okay. All right. Questions about that? Hope that isn't too bad. No? Perfect. All right. Now let's look at one more example here. Okay. Just another example here. Another one. Like I said, 3 of these I need to do because they're very specific. So, but they offer the most insight. Okay. So we're going to look at number 25 here, one of my favorite problems here in the textbook. So I always give this question here every time. So I don't think there is a time where I haven't gone over this question. I really like this question a lot because it's, again, the practicality behind this question, just like the police problem, is just like, wow, really good. Okay, well, let's go over this together here. Just trying to put that in the correct frame. Okay, so a forest ranger needs to estimate the height of a tree shown in the figure. She sights the top of the three, she sights the top of the tree through a clinometer, a device that gives her the angle of elevation as 68 degrees. We've already talked about angle of elevation, so we know what that looks like. She is standing 32 feet from the tree, and it is 5.5 feet from the ground to her eye level. How tall is the tree? So this picture here is a very good representation of what we're trying to find. Okay, so let's take a good look here at this problem, and let's see how we can find the height of this tree here. And again, if they don't actually do it by hand, for example, finding the height of a tree, some trees they do find by hand, uh, but let's say it's a tree that stands straight up, then much easier to do it with a surveying tool and some trigonometry, standing on the ground rather than hoisting yourself all the way up to the top. So saving time, saving energy. All right, so let's take a good look at this. All right, and let's see how we can solve for this. Again, let's draw our right triangle here in this instance. Okay, so let's go ahead and cross this out. Okay, so here we have the tree. So the tree is right here. And according to the picture here, we're 32 feet away from the tree. And we form an angle of elevation looking through this device here at a 68-degree angle. Now, we're trying to find the height of the tree here specifically. But remember, our eyes are 5.5 feet above the ground. So let's not forget about that, okay? Okay, we'll factor that in here near the end. All right, now again, we're going to try and solve for x here. So, need to decide what trig function should we use here in this instance? Should we tangent of 68? Okay, so can you tell me what's tangent of 68 equal to? I agree, it's tangent of 68. What is tangent of 68 going to equal here in this problem? x over 32. Good. All right, so far so good. Now, what should we do next? How are we going to solve for x? Multiply 32 to both sides. Okay. Let's multiply by 32 on both sides. So on calculator here, we're going to do 32 tangent 68. We're going to go to 2 decimal places here. Anybody tell me what we get for x here in this case? What do we get here? 32. 79.2. Okay, good. Now, that's correct. 79.2. I totally agree. Now, remember here, this person, one thing that we have to factor in, we have one more step to do here. This person was 5.5 feet. When they looked through the special device here, the clinometer, this person, she was 5.5 feet above the ground. She's 5 foot. She's 5.5 feet tall. So we're going to take the one added extra step here of taking the 79.2 and adding by another 5.5 feet to reflect the adjustment we have to make for the individual who's looking through the clinometer here. So if we add 5.5 here, add 5.5 feet, we're going to get our final answer here of 84.7. That little added extra step here just to account for the person's height is what we want to take into account for this. All right. Any questions about that one in this case? I'm going to do one more problem here, which I feel is important. No? Okay. Let's move on to the last word problem I want to specifically look at here. Again, there's very specific problems I want to look at in a particular, actually even in a particular order. Like I said, I don't want to go over it too fast, so get going back a couple pages here. Okay. All right. So I want you to take a good look here at number 12. So number 12 here is with these two circles that you see here. Okay. All right. So it's a drafting problem here. So it says find the angle A in the figure. All right. Express your answer in decimal degrees. All right. So we want to find the angle A here in the picture. Okay. We're given a couple circles with a couple diameters. We're given the length of one of these diagonals. Okay. And we're trying to find this angle A up here in the meantime. Okay. So let's draw the triangle here at the very least, and then we'll come back to the picture here. Yep. All right, so this is our angle A in here. This is what we want to find, this angle A. Now we're already given one value here, so let's go back to the picture here for just a moment. So that's 8.105. So we're given 8.105 here so far. That's just given to us, no problem. All right, let me go ahead and expand this out a bit. Here. Okay, let's look at the picture here a little bit more carefully. Actually, I'll switch sides with this. All right. I always get this wrong. Whatever. All right, we'll come back to it. In any case, let's take a look and we see if we can determine based on the picture what any sides of these triangles are going to be, because we're only given one side here. We're given this 8.105 inches. Fair enough. Can we determine this bottom side or this side here? Which one of these sides can we determine based on the information that we're given here? Can we determine the bottom side or this right side here? Which one do you think? The bottom leg or the right leg of this right triangle? Which one can we determine here? The right. Okay. Okay. And all right, you can determine the right. Okay, so Breton and Jerome say the right. That's fair. Now, how do I know what this right side is going to be? Okay, I'm going to agree with you guys, but how do I know what this right leg of this right triangle is going to be here? What's that going to be here in this case? What is this length here? Got from here to here. Hmm. Actually, can anybody tell me here? Here's a hint. Here's a hint for you guys. From the radius. That's right. That's right. That's correct. So let's look at this carefully here. 5.875 is a good guess. Not quite, though. Let's take a look here. All right, so you have to be very careful about the wording here. This is why I'm just going over this problem here very slowly. Now, this is from the center of this circle here, the center of this big circle, all the way to the very top here of this circle. Now, this here is the radius of said circle. However, you have to be a little extra careful here. In this case, we're given a diameter of that circle, not the radius. So we know what the diameter is, but we don't know the radius of the circle. But that's not too hard to find. Okay? So here in this case, if we're trying to find this side right here, we're just going to take the radius here, which is going to be 5.875, and we'll divide that by 2. And we're going to find the length of this side right here. So let's plug that in and calculate real fast. 5.875 divided by 2. What do we get here in this case? That's 5.875. Let's that divided by 2. $2.9375. Good. Okay, so now that we have that, all right, we're going to put this over here on this side. All right. Now, let's go back to our picture here. Okay, so now that we have the full picture in frame, let's take a look here. Our goal is to solve for angle A here that we've marked here on this figure. Now, we have to use one of the 3 trigonometric functions in order for us to do that here. So are we going to use sine? Are we going to use cosine? Or are we going to use tangent for this particular example? What should we use here? Should we use sine, cosine, or tangent? So is it sine, is it cosine, or is it tangent? One of those three is going to fit the bill here. Think back to SOHCAHTOA here, okay? That should give you a good, clear hint. Which one would fit the bill here? Would sine, cosine, or tangent fit the bill here based on the sides of the triangle that we're given? Guess this is a tough one. That's why I like this one to be last. Tangent, okay? You say tangent. Now, tangent here is opposite over adjacent. So remember, we're taking the angle A here. What sides of the triangle are we given in relative circumstance to angle A? Remember, opposite would be here. Like if you wanted to label your sides here, opposite would be here, because this is the side opposite. Adjacent would be right here, right? And hypotenuse would be right here. Adjacent just is a fancy word meaning next to. Hypotenuse is always the long diagonal part. Cosine of A, that's correct. So this is the point that I have to make here is like CAH, right? Adjacent and hypotenuse. We have the adjacent side, we have the hypotenuse side. So I want to use both numbers here in this case. So that's why cosine is the best choice here in a problem like this. Okay, is because we have the adjacent side that's given to us as some number, and we also have hypotenuse is given to us also as some number. So we have cosine of capital A is equal to adjacent, or this is adjacent over hypotenuse. So adjacent here is going to be 2.9375. We're going to divide that by the hypotenuse of 8.105. Okay, well, I need to solve for big A, for angle A. So what should I do next? How do I solve for angle A? What do you think I could do next here? Don't forget what we talked about in the last section. That'll be helpful here. Yeah, the inverse cosine. Very nice, right? So exactly, this is where we're going to use that inverse cosine that we just talked about here at the beginning of class. So we're going to take inverse cosine of both sides. Now I'll clean this up a bit because it doesn't look very nice right now. But here we get A is equal to cosine inverse cosine, whichever way you want to call it, 2.9375 over 8.105. Okay, again, we're going to enter that into the calculator there. And let's make sure we all get the same result here. So I'll do it out, but you guys do that out on your calculators as well. And again, we'll go to 2 decimal places here once again. And can anybody tell me what we get here for angle A? All right, 68.75. That is correct. Very good. That's right. 68.75 degrees is spot on. Nice job, everybody. All right, and that's going to be your final answer for what angle A should be in that figure. Okay, good. All right. So, are there any questions here from this last section? I guess I should mention that here. Any questions at all? Okay. All right. So I do have a couple of things that. Okay, no problem. No problem. Good. 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 All right. Now I do have a couple of things I do need to discuss here. Okay. So let's talk about those things that we definitely need to talk about here for this course. All right. So I'm going to go back here to the textbook here, and all right. Now I want you to take a good look here. In that, let's go over a few things here. All right. So let's give you the rundown here. That in effect is effectively we are officially done with the textbook and all the new material. All right. So that effectively is donezo for the any new material that we're going to have from this point forward. Now, the chapter 6 to 10 test has been put up. You probably have seen it if you've been on my math lab. All right. Again, everything here is open until next Friday. Now, I did get an email saying that final grades were due on the 15th because technically we leave off early for the second 8-week course. But I didn't feel that that was very fair, and you also run concurrently with the 16-week class, which does get a few more extra days. So I didn't feel that it was very fair to disenfranchise you, and so I'm going to keep, again, I'm not going to be like, oh, yeah, you get shafted for a few days. Like, no, you're going to get the same amount of time that they do. Okay, so everything's going to be open for you up until the 18th as well for you to finish up. Okay, there's a practice test here over chapters 6 to 10. All right, and then also the final exam here is also due that same day as well. So one of the things that I highly suggest that you do is to basically get everything done by the 18th as much as you can. But the first and most important priorities here is to, of course, do the exams here. Make sure you do that out. Now, as for the final exam here, I want to go ahead and describe the final exam in a little bit more detail to be fair. Okay, now as you know here, if you looked through the first practice test there, chapters 1 to 5, or you looked at the second practice test here, chapters 6 to 10, there are 50 questions of each. Okay, now what I decided to do here for the final exam is I took 25 questions from the first test, I took 25 questions from the second test, and I put that all together into a final exam. So if you want to basically go over final exam practice, basically look at the practice exam questions, practice test questions from chapters 1 to 5 and chapters 6 to 10, and those will give you the best insight to basically they're going to be the same type of questions that you're going to see from those practice tests. And I just kind of picked 25 from each and I slapped it together and I called it a final. Okay, that's all it is. Now I did give you more time. So compared to the first two exams, again, there's gave you 6 hours of which to finish here. They're not 6 hours, 8 hours, pardon me, for the chapter 1 to 5 test. I gave you 10 hours here and 3 attempts for that. So you get 3 attempts, you get 10 hours of which to finish. Again, I suggest you start early so that way you'll be able to work at your own pace. Also, be able to finish up all the homework there, all right, in the meantime, all the way that goes all the way up to section 10.3. All right, so again, homework is a very large part of the grade, but also getting those exams done. And again, you have until the 18th there because I want to give you a fair amount of extra time. Otherwise, it would be like until like the 13th. You'd have like 6 days to finish all of it, and that's really bad. So I'm not about to do that, of course. I'm going to give you the whole week of which to finish that, and then I'll enter in the grades a little late, but I think it's fine. So I don't think that's too much of a problem. Um, are there any questions about the exam or the homework or anything like that? So I just wanted to be as transparent as possible about what to kind of expect here moving forward. And again, you have from now until next Friday of which to finish any and all of the material there. Now, what we're going to be doing here next time is, even though we're not doing any new material, if you have specific questions you'd like me to go over or anything of the like here, feel free to go ahead and ask me, and I'll be more than happy to cover those type of topics with you at that moment in time. So that'll be effectively, just to let you know, next class is effectively going to be our final class, our final lecture for the semester. So yeah, after that, it's pretty much you guys will have to finish up that stuff here on your own. I'm going to be posting something to Blackboard to give everybody else a friendly reminder. So does homework? Absolutely, it does, 100%. Read the syllabus, 100%. Homework is a very significant portion of the grade. All right. So again, you have to do all the homework there. Homework tests, those are all your part of your final grade there. So again, you got 11 days of which to finish up any of the homework there, and doing all the tests there. From day one, homework has been always part of the final grade. So again, people have done good on the tests, but they didn't do any of the homework, and then they don't end up passing. So I don't want that to happen to anybody here. I want people to be like, okay, hey, take that seriously. And all of you who've come to these lectures here I see are taking it fairly seriously. So pretty pretty happy with the progress there. But I want to give you a friendly reminder here, until the end of the semester. So, are there any other questions that you guys may have? Okay. All right. So, this is where we're going to end off here for today. All right. All right, guys. Thank you very much for coming on out here to the stream once again. Okay, I'm going to be back at 1 o'clock here today. So maybe like an hour and a half or so, I'll be back. But for you guys there in 097, again, come back on Wednesday. That'll be the last official class there for us. Okay. And again, if you have any questions you'd like me to go over, feel free to ask me, and I'll be happy to go over those topics with you. All right. In the meantime, though, again, finish these tests, finish those homeworks. Okay. Again, they're due next Friday, so that way at midnight. Okay. Be sure to save your progress up until then, and then I will be compiling final grades after that. Okay? Do these lectures count toward the final grade? No. Just the homework and the tests. That's it. Homework, test, and final. That's it. But these lectures are very useful for you asking me direct questions, so if these lectures counted toward the final grade, then I think a lot of people wouldn't be passing. A lot of people don't show up to these live streams, but I understand why. So people are working and doing other things. So and in reality, a lot of people work until the evening. Typically, these classes that we have for 097 would meet in the evening because usually everybody's off work by then. But yeah. Okay. All right, everybody. I want to thank everybody once again. All right, for coming on out. All right, I will see you all on Wednesday. You have yourself a wonderful day. All right. Yeah, thank you, Anna. Hey Anna, how's your hubby? How's he doing? Is Kenny feeling better? Thank you for those kind words, Anna. Oh, okay. Well, I'm hoping that he'll feel better soon. Okay. Obviously nobody wants to have the flu or whatnot during this time, but hopefully he feels better during the week and he can start feeling 100%. I guess that's the last thing I'm going to say here is that yeah, but wearing a mask inside, totally understandable, completely understandable. At that point, you kind of have to. Totally understandable. Don't worry, it's hopefully things will start to ramp up soon. So, all right. Well, Anna, you know what I think? I hope that your husband is your husband and yourself and everyone here in the chat, I hope everybody here, stays safe, stays healthy, and stays sane. If you're coming back to my stream here, I'll be back in an hour and a half. Um, if not, then I'll see you on Wednesday. All right. Everyone, have yourself a wonderful day, and we'll take care. We'll take it easy. All right. Have a great one, everybody. We'll see you later. All right.